Hello, this is Pete Catropi. I'm Chief Scientist Opalytics, and today I'm going to be giving a demo on Opalytics Cloud Platform notebooks and how the Opalytics Cloud Platform can publish a Jupyter-style notebook for use by users. So today's example is based around the Germany Center of Gravity model. That's a homework assignment in this supply chain network design book, of which I'm one of the co-authors. So if you want to get this sample data, there's a link associated, there's a website associated with this book that can give you the sample data and the notebook files that I'm using today. So I've already uploaded the data, and I've used a notebook to convert this raw Germany data into plants and carriers and lines, and then I've run an optimization solve that's tried to minimize the average service distance. And the next step is I'm going to use a notebook to create a custom report that shows the percentage of demand serviced within different distance bands. So to do that, let's go to the notebook section of this same project. Let's upload a notebook. Customer service distance demand report. So this is the center of gravity IPYNB file is written with sort of zero vendor lock-in in mind. So that is a notebook that you can configure very easily to either run on Excel file data or run on Opalytics Cloud Platform data. So as you can see with the customer service As you see with the customer service demand report notebook, this one is just set up to run off of the cloud data. So you get you find your input set, also find your output set, that's your solution, and then you walk through and you compute your report. So I'm going to set the input set for this notebook to be the Germany data set. So now this notebook here is connected to this same data set here. And now it should work fine if I just execute all the cells. And so that's this button up here. And I'm not going to jump through the Python logic very carefully. This is all just ordinary Python being done with data frames. So you can do your own deep dive on that. That's a Python deep dive. The point here is it creates this table, this report right here, where you have distance in kilometers. And you say for each of these distance bands, you see the units of demand that fall within that band, the percentage of total demand that's serviced by that demand, and then the cumulative percentage of total demand. And this report, CSDR report, has now been saved over here. So if I refresh, bear in mind this sometimes it's a little slow on this platform that I'm using, this portal that I'm using, but you can see we created this custom report, right? Customer service demand, right? So the little exercise I'm going to go through here is how can I reconfigure that notebook so that it would be easy for a developer, so it'd be easy for a user who doesn't really know anything about Python to regenerate this report with different distances, right? So this sounds like potentially a challenging task. Good luck doing that with a true Jupyter notebook. But because at Opalytics we are sort of recreating a lot of the Jupyter work in order to support Jupyter consistent notebooks, we can do a few more sophisticated things. So specifically what we're going to do here is we're going to generalize this concept of these parameters, right? So this is something we're innovating with, which is we're calling it parameterized notebooks, where instead of setting things like where is the data coming from or what are the distance bands, so here's the distance bands, they're a little ways down right here, right? Instead of setting the distance bands as a hard-coded block of code in the notebook, or instead of setting the path to the data as somehow hard-coded, you can just capture your data path or capture data like the distance bands in a generic way, and then a user who doesn't know anything about Python can just set those parameters in order to run the notebook. So we're going to do that. what we're going to do is we're going to add 4 parameters. We're going to call them band 1 and 2 and 3 and 4. We're going to give them these same defaults down here, 25, 50, 100, 200. So that's going to be these default values. Bear in mind, sometimes it's a little fussy capturing the defaults when I do this. So let's see if it works. And it didn't quite work. So let's try tweak it a little bit, see if it will remember the defaults this time. There it goes. Okay, good. So now we've created this set of parameters, and let's save our work. As always, you always want to save. So now we have defined these parameters, 25, 50, 100, 200, right? These are the internal distance bands. The code is smart enough that it always figures out the maximum distance band if a maximum distance band is needed. So now I just need to change this logic here, where instead of D-bands being these hard-coded values, D-bands actually needs to be reference these parameters up here, right? So how am I going to do that? Well, there's a little code hint here that tells me how I can get just one of the bands. That's how I get band 1. All right. And bear in mind, I'm doing this a bit on the fly here. So D-bands, I want it to be a sorted list. And each element of the list is going to be a float, right? So we're working on changing the types of these parameters. But for right now, these parameters are all just floats, and you just cast them as you need to. But we're expanding the functionality for that. So I need to cast it to a float. You can see I've got that little green thing. It's balancing my parameters by parentheses, so it's easy to see. Okay. And so that's my list. My list is from 1 through 4 inclusive. I want to turn that, create a band for that list to get the parameter for that band, or get the parameter for that string. Then I convert that parameter value into a float, and then all of those, whoops, I got this backwards. It's actually sorted. I want to sort it and then turn that sort into a list. Okay, that looks good. So let's save that. And now let's clear all the output. And let's see if it works. Here it is, kind of walking through. Seems to be working. Seems to be working. Okay, huzzah. Looks like it all worked, right? So now we're going to pretty it up a little bit and then save it as a public notebook. So by prettying it up a little bit, we're going to give a little prompt right here with the bands. It doesn't really matter where that prompt is, but I'll put it here. Consider cell above. And it's going to be a markdown. I'm going to say right. So, and then here is the key thing. I'm going to now make this a published notebook. So a published notebook is one that has some extra metadata controlling what sort of functionality, what sort of cells are hidden, and what sort of cells are presented to a user, right? A user will come along and run this notebook as a published notebook, right? So most of these cells are supposed to remain quiet. There's just a couple that should present their output to the user. So obviously the markdown should be visible. Obviously the result of the report should be visible. and the diagnostic that lets you know that the report is being saved should be visible, right? So just those three things need to be visible. So now we'll save that. It's been saved. So now we go back over here. And from within the Germany data set, we can now run a published notebook. And again, that's the, if there were more than one published notebooks, we would see more than one choice there. And you can see, it gives me some good information. The defaults are already there. So let's just run it with the default values. And it worked. And these are the same data that it created previously. Now, if you want to play around with this, if the user wants to play around and create a better report, it's very easy to do that. So I think I've got a pretty good guess as to what works here. Those numbers will give me a little bit of a more even breakdown. So as you can see, the numbers are a little bit uneven, some bigger gaps. It makes more sense to try to hit kind of the median points. That's a little bit closer to hitting the median points. A couple of big gaps here, but if I wanted to actually compute the median distance bands, I could have rewritten the code to do that. But I think I've demonstrated my point. See, a developer that doesn't know, or sorry, a user that doesn't know anything about code can now create whatever distance band report he wants to create using some fairly sophisticated Python, but all he sees is some markdown giving him instructions, some parameters to fill in that are easy to set up with default values, and then he just sees the results and diagnostic information. Okay, thanks for your attention, and I hope to join you on other Opalytics videos.